This is video number 9, the law of conservation of matter. Matter is conserved. That means that when we have a chemical reaction, the matter that we begin with, it has to equal the matter that we end with. So in this case, we have reactants of sodium and chlorine producing product of sodium chloride. The amount of sodium and chlorine that react must equal the amount of sodium chloride produced. And so that's what we're going to emphasize in this section. Here's a plot of the mass of sodium, reactant number 1, relative to the mass of chlorine, reactant number 2. If we add the two up, we'll get the product. Okay, that's what the law of conservation of matter is telling us. So I'm going to go through and do some calculations here. The first thing I want to know, if I have 10 grams of chlorine reacting, what mass of NaCl will be produced? Well, I'm going to go over here. 10 grams of chlorine is going to require about 7 grams of sodium. So 10 plus 7 equals 17 grams. So my total mass, if I completely react 10 grams of chlorine, the total mass of salt produced will be 17 grams. If I go to my next one, I say, okay, what about 10 grams of sodium? If I use 10 grams of sodium, what is the total mass? Okay, well, now I'm going to come over here to the mass of sodium, come across, and I'm going to hit somewhere about right here, come down about 14.5 grams. So my 10 grams of sodium plus 14.5 grams of chlorine equals 24.5 grams. Probably not to that precision, maybe 25, but it's definitely something we can use. Now, let's postulate this out from a total. And this is where you're going to have to do a little thinking to get through the graph. The third problem, we're going to say, what if we have 40 grams of NaCl? How much Na was used in the reaction? Well, now I have the total mass. I can look back here and I know if 10 grams of sodium was used, it produces 24.5 grams. Now I want to know the unknown amount of sodium if 40 grams was produced. So we're going to set up a ratio. We'll say, okay, the X sodium relative to 40 grams NaCl equals, and up here I know 10 grams of sodium produced 24.5 grams of NaCl. I can cross multiply. So we're going to drop the unit and the Na off, but we know what we're finding. So I'm going to have 24.5 Na equals 400. 40 times 10. All I did was cross multiply. 24.5 X. X is Na. Then X is going to be equal to 16.3. So if I produce 40 grams of sodium chloride, I can go to my graph and pull a data point off anywhere on the graph. I pick the 10, but I could have gone to 20 and determine it, or 15, whatever. Pick a data point off, use that data point, just make sure you're comparing the same values. Now let's go one more step, and let's say we're going we've got 12 grams of NaCl, and we want to know the amount of chlorine. Okay? So again, I know the relative amount of chlorine to total NaCl. 10 grams of chlorine produces 17 grams of NaCl. Or I could use this data point. Obviously, 14.5 grams of chlorine produces 24.5. It doesn't matter. I just need some point off the graph. Okay? So I know that my unknown Cl2 relative to 12 grams NaCl equals my 10 grams of Cl2 relative to 17 grams of NaCl. I'm going to cross multiply. I'll get 17x equals 120 Solve that for x, and x equals 7.1 grams. So, in summary, the law of conservation of matter tells us that the total mass reacting must equal the total mass of product produced.